Define gravitational potential at a point. The energy required to bring 1 kilogram or unit mass from infinity to the point. Explain how the equipotential surface in figure 2 shows the gravitational field is not uniform. The potential difference between the lines is constant, but the distance are not. Equipotential are curved. 0.3 joules per kilogram difference between each, but not the same distance. Change in potential over change in R is change in potential. The V over the R, the inner is 0.857, and that's how you get it. And the outer is 0.625, and that's how you get it. Therefore, G is not constant because it's changing. Question 3.3. Calculate, using figure 2, the escape velocity at the surface of the moon, and the radius of the moon is 1.74 times 10 to the power 6 meters. When we're thinking about escape velocity, we'll be thinking about energy. The kinetic energy is equal to gravitational potential energy. A half mv squared equals big G m little m over r. We can find the mass of the moon by using V equals big G m over r, and that would be rearranging that V r over big G. So therefore m equals, we take the first curve from the surface of the moon, 2.23 times 10 to the power 6. That would be the distance, and the potential is going to be 2.2 times 10 to the power 6 over the big G, and that gives us the mass. With the mass, we can take that mass and plug it back in here, because V squared equals 2 big G m over r. V equals root 2G m over r, and then we plug these values in with the radius, and then we get V to be 2.4 times 10 to the power 3 meters per second. This is two significant figures.